Welcome, ladies and gentlemen. I admit I'm running a little bit late. I have had a long and busy day, but I'm here. So, another week. I'm Kino with STEMwithKino.com, and I'd like to welcome you, all the new people here in the room and watching the video. Every week we do Federal Aviation Administration and Military Aptitude Test Prep. So that includes the ASVAB, the ASTB, the AFOQT, the SIFT, the OAR, and all Federal Aviation Administration tests. Guys, just somebody in the room, give me a shout out if my audio sounds good. Please. Okay. The people say we sound good. Okay. Alright, so here we go. Oh, man. What a week. Alright, so let's get those questions going. And I'm checking the email now. First thing I'm going to jump in, a lot of people don't really have the concept of absolute value. And absolute value does not really care about, when we talk about absolute value, we're talking about just that, the absolute value of something. Like how many units is this really? It doesn't really matter if it's running in a positive or negative direction. It just deals with distance. So it'll never be negative. It'll always be positive. For instance, let me close this out. And let me open this up. Give me a minute, guys. I'm getting it together. Boom. Bang. And open that up. And okay. Here we go. So absolute value. So let's say we have a situation where, and thanks, guys. Please continue to keep checking in. When we have an absolute value question and a bad marker. Alright, so we have an absolute value question, and let's say it was something like, I don't know, 7 plus P, and the absolute value brackets equals 7. Well, what happens here is that we have two different equations that we're going to have to solve. We're going to have to solve 7 plus P equals 7, which is originally there, and then 7 plus P is equal to negative 7. Alright, so I'll put a line here. It's two different equations. Alright, so we have to isolate P. If 7 goes to the other side, it becomes negative, and then P will be equal to 0. And if 7 goes to the other side of that, and it becomes negative, P will be negative 14. So the solution set, those little braces that we use, is 0 and negative 14. That is a solution set. So the absolute value of 7P equals 7 is actually, there's actually two answers when we solve for P. Now, a lot of people, they come up with the answers and they don't test it out. So let's test it out. Now remember, as long as this content and this container is in here, it doesn't matter if a negative result is in there. We're going to look at it as positive. So let's put a 0 in here. 7 plus 0 equals 7 in absolute value. And it does. And then if we put negative 14 in here, 7 plus negative 14, remember, this is in the container of the absolute value. Now, you are going to get a negative 7 because the positive is going to distribute to remove the parentheses, and it'll stay negative, and then we'll have negative 7, but it is within the absolute value bracket. So even though we have negative 7 within the absolute value brackets, we look at it like 7. And people, type clear if that was clear. All right. Outstanding, outstanding, outstanding. I'm liking all this, man. You guys are... Okay. We've got at least 2 clears. All right. I think some other issues that we've been having that I want to address. Well, let me check the email first. Uh-oh. Boom. You guys are not playing. Okay. See what we got. Okay. Here's our first question. Fort Shackelford has a large pool in the shape of a pentagon. If the Morale, Welfare, and Recreation Office wants to hire a lifeguard for each side of the pool, all right, what is the minimum number they will need to hire? Lifeguards are limited to 1 4-hour shift per day with a 30-minute break, and during the peak meal break, and during the peak, pool stays open from 10 to 8. All right, so line by line, we have to look at the details. This is a word problem. And the answers are 4, 5, 10, 15, or 16 lifeguards. All right. My other computer's on. Give me a sec. The noise is going to bother me. Alright. So, guys, first off, can anybody in the room tell me how many sides are in the pentagon? I'll wait. Very good. So everybody agrees that there are 5 sides to a pentagon. Now, with the question, let's look at this question line by line. We're going to go line by line and we're going to diagram. All right. So there's 5 sides. I think it looks something like, well, it's kind of like they go in like this. So 1, 2, 3, 4, 5 sides in the pentagon. And we're dropping our mouse. So there's 5 sides of the pentagon. And they want to know the minimum number of lifeguards they will need to hire. Now, the lifeguards are limited to a 4-hour shift per day. They get a 30-minute meal break. And during the peak summer session, or season, the pool stays open from 10 to 6, or it says 10 to 1800, which is 8 hours. So we have our 5 sides. So we're going to have 2 lifeguards, and this is just 4 plus 4. Or maybe we should focus on the number. So for complete coverage for the day, we're going to need 2 there, 2 there, 2 there, 2 there, 2 there. All right, now they want to hire a lifeguard for each side of the pool. So they will do that throughout the day, having 2 lifeguards. I want to go with C right off the bat to get coverage. And let me see. Again, I said the answers are 4, 5, 10, 15, and 16. So the lifeguard's only limited to 4 hours per day. It's an 8-hour period from 10 to 1,800 hours. So on each side of the pool, we're hiring a lifeguard. So I guess 10 to 2 is one lifeguard is going to be on, and then from 2 to 6, the second lifeguard will be on per side. So we would have 2 per day there, 2 per day there, 2 per day there, 2 per day there. Just look at all the sides, multiply by 5, 10, and you should be done. And the presenter of that question, please check the answer. Julia, why'd you put in 78? That's not any of the answers. Okay. Yeah, I say 10. Julia presented the question, so we're waiting for her response. But I believe it's 10. But give me a couple of clears. And please hit the like button or the dislike button. You send questions to my email. Sorry, I fell on my head a lot when I was a kid. I'm going to, let's see this. So this is in transit. I've been literally waiting for a package all day, guys, and it has not gotten here. I am pretty pissed about that, but it's okay. All right, back to my live stream. I was just saying, like, maybe they would have been like, "Oh yeah, your package is there," but no. It is the well, I'll talk about it in a little bit, but yeah, send all questions to kienothomas@gmail.com. So Keno Thomas at gmail.com. All right. Where is we? All right. Back to the, and Julia, did you ever come back with an answer? Oh, that's not your, okay, Ryan, that was your question. I apologize, Julia. I kept saying your name like, Okay, so it is 10. All right. Okay, this one again, I believe is from Ryan again. If a carpenter cuts the largest possible circular tabletop from a, I got some feedback. Sorry, guys. Okay, that should do it. Okay. If a carpenter cuts the largest possible circular tabletop from a piece of wood that is 2 feet square, how much wood would be left over? Wow, that's evil. What? So, we have a piece of wood that is 2 feet by 2 feet by 2 feet by 2 feet. And we're going to cut a tabletop. And this is not like the perfect circle, but I just want you guys to get an idea of what the carpenter is doing. All right. So, if the carpenter cuts the largest possible circular tabletop from a piece of wood that's 2 feet square, how much wood would be left over? Use 3.14 for pi. All right. So we have 0.86 square feet. Really? 1 square foot. And these are all square feet. 1.72, 1.86, and 2 square feet. Now, what I would do is, we got to look at this. We need to know the area of a square, which is length times height. And then we need to know the area of a circle. The area of a circle is pi r squared. All right. And both of these are going to come out in square feet, whether you're calculating area here or area in the circle. All right. So if it's 2 feet by 2 feet, that means that the radius is 1. Okay. Radius equals 1. Because it's 2 feet across, that would be the diameter. So the radius is 1. We're going to take, so we know that we have 4 feet in this square. Now, if we want to know how much wood would be left over when we cut out the circle, then our area that we calculate for that is going to be removed, so we subtract it from the 4. So pi is 3.14. R is 1 squared. And I see 0.86. The top one. I see it already, but 4. This is r, which is 1 squared. So pi r squared in this situation. The radius is 1. So that we put it in there times squared and then times 3.14. So 4 times 3.14 is 0.86. That is what's left of these little, I guess, the little throwaway or scraps after we cut our tabletop out. That wasn't too bad. Ryan, is that the answer, sir? It should be. It should be, but, you know, I always like when people, they come back and they say, okay, all right, you know, not like it's my ego, but I like to give you guys like a nice clear-cut way to go on after these questions. So the thing is simply just line by line and diagram, and I say this every week, line by line, diagram, line by line, diagram. It's never going to go away. He doesn't stop saying it. It's like, he doesn't stop saying it. Wait, 1 squared is not 4. You're right. Here's the thing. The whole piece, before we cut the table out, is 4 square feet. All right. Now to find out the part that we're going to eliminate out of that 4 square feet would be the area, which is 3.14 times r squared. R squared happens to be 1, which is 1. 3.14. So 4 is 3.14 subtracted from 4, and we have 0.86 square feet left. All right. And does everybody in the room agree with that? I want us to all be in agreement. And if somebody gets hung up, I really don't want to leave someone behind. Please hit the like button or the dislike button. Okay, so we're clear on that. All right, great. These are really good questions. Let's look at another one. All right. Go, Ryan. He's dropping these nice questions. All right. Okay. I've done this question to death. Oh, wow. Okay. I'm going to do it again. But actually, I wish... Damn it. Yeah. I've done this question to death. I'm actually just going to, send you a video of that question, Julia. I'll send it to you personally. Because I try to keep the content, fresh. Okay. Now, in this situation, I will do your second one because it's concerning electronics or electrical circuits. And we don't really do enough of that on this channel. Let's see here. If two resistors and a battery are arranged in each of the above circuits, which circuit arrangement has the greater arrangement? It would be circuit A. So what they have here, folks, is we have a battery or a power source, or a voltage source, I should say. Right, and we have a resistor here, and we have a resistor here. All right, that is circuit A, and that is in series. Then they have a circuit in parallel. Now, they really don't talk about, I guess you're just supposed to assume if two resistors and a battery are arranged, you're supposed to assume that they're the same, they have the same resistance. So we have a resistor here, we have a resistor here. And these resistors are in parallel. Meaning that there is more than one path for electricity to flow. So this is a series circuit. Everything runs in series. One circuit, one path for electricity to flow. Where this system has two paths to flow. This has the most resistance. The reason why is because you can tell in the formula for resistance. The formula for resistance in a and this, let's say this is R1, resistor 1, and resistor 2. This is resistor 1, and this is resistor 2. All right, I am going to do more videos on electrical stuff because I really don't do enough videos on that. But the formula for resistance total in a series circuit is R1 plus R2 which means plus R3 plus R4 plus R5, however many resistors. You get your total resistance like that. All right. So let's say these were 2 ohm resistors. That's what you got to do sometimes with these questions. You got to be like, okay, I'm going to assign a number to these resistors. So it'll carry some weight. If I just say, you know what, 2 resistors in a battery, that really doesn't mean anything to me numerically. So I'll say use a small number, 2. 2 ohms of resistance here, 2 ohms of resistance here. So we have 4 ohms of resistance because the R1 plus R2 is 4 ohms. And let's say we have a 2 ohm resistor here and a 2 ohm resistor here. I know the formula for resistance in a parallel circuit, and it's like 1 over R total. So already we're dealing with a fraction. So 1 over 2 plus 1 over 2. Okay. Automatically, these two resistors are only going to give me 1 ohm of resistance versus 4 ohms of resistance just by adding, because in parallel it's a fraction. It's a fraction of the resistance. So it's like R1, R2, 2 plus 2, and then 1 over 2 plus 1 over 2, which is a whole. It's just one ohm of resistance. So circuit A, well, actually the options were circuit A, circuit B, or they have the same resistance. Circuit A has the greater resistance, B has the weaker resistance, and C, they have the same resistance. Throw that out. You can check that. You don't even need to come back and say, yeah, Kino, that was right. I know circuits. Okay. Number 6 comes all the way from way out west. Way out west. Phillyana. All right. Okay. A lot of times, you guys see fractions and you freak out. Stop doing that. Watch more Kino. Now, there's 2 ways I can do this problem. Here's the problem. It's just 1. And then we have 5 plus x over 6. Now, there's 2 ways I can do this. Hold on. Let me get my big screen on. All right. There's 2 ways that I can do this. I can multiply both of these sides by 6. to get to my answer, or I can just set up a new equation. All right, I think setting up a new equation is the easier way to do it. So I always give you guys a parallels, right? If I had 8 over 4, that would be equal to 2, right? But you got to look at this like 4 times 2 is equal to 8, all right? So 6 times -1 is equal to 5, 5x. All right, so I would just set up an equation. -6 is equal to 5 plus x. 5 jumps to the other side, and then becomes -11, and that would be x. All right, and to test it out, I would take this -11 and put it in x, -11. All right, so -11 plus 5 is -6. What is 6 times -1? -6. I'm done. All right. Is that clear to everybody? Is it the mechanical one? Outstanding, Ileana. And I'd like to thank all you guys for taking time out to come through, present questions. It really means a lot. And you guys make me look super smart. I'm just being silly. Okay, number 4. This is a... All right, zoom in, buddy. I think this is a 2-step equation. All right, when we look at this, we have a plus 5 is equal to -5a plus 5. All right, so all we want to do is, number 1, I want my variable to be on the side where it's bigger and that is positive. All right, so 5 is going to jump the equal sign and become positive 5. So we will have 6a. But this 5 is going to go to the other side and become -5, and then this positive 5 is still there. And so this actually is going to be zeros, which means 6a is equal to 0. So there's only one thing that can be multiplied by 6 to give us 0. And that would mean that a equals 0, guys. All right, so that is the question. Keep the questions coming. All right. Okay. How is the weight of a person in an elevator affected if the elevator accelerates upwards, accelerates downwards, and is at rest? Our answers are, I guess, and it accelerates upward, increases, decreases, remain constant. So the answers are like answering the question. So let's explore. All right. What I like to look at is, I like questions kind of like these. So we're either going to be in 3 type states. How is the weight of a person in the elevator affected if the elevator accelerates upwards? So we're in this elevator and it is moving upward. All right, that is one situation. Or we could be in the elevator and it is moving downward. All right. And then the third condition is it's on the ground floor, on its piston, and it's at rest. So we have a human in here in each case. All right, I gave him, hold on. All right, so there's a human in here in each case. So we have to look and analyze forces. All right. Let's look at remaining at rest, because I think that's the most simplest situation. it's at rest. Gravity is putting weight on the elevator, and the elevator is just merely supporting the person. How is the weight of a person in the elevator effective if the elevator accelerates upwards or accelerates downwards and is at rest? So, okay. I think that's a different condition now. Because it's like accelerate upwards. I don't know. It's giving me three different. Okay. So, all right. Let's say they mean that this elevator is going to go up, accelerate upward, and then come to a stop. I think that's what they mean as I'm reading through this again. So, as we push up like this, the weight of the person in the elevator effective as is, your weight is going to be the same. But when you stop, you come to a full stop, you're actually going to go, your inertia is going to actually want to keep going up. And you can feel that when the elevator stops rising. So the weight on the elevator is going to increase. When it stops, it's going to decrease. And then it's going to remain constant, I think. Decrease, okay. That's what, to me, but it's this is kind of confusing. How's the weight of, is this a Trivium book? I'm sorry, Trivium. I'm really going to stop talking about you guys. They're throwing darts in the break room and Kino. All right, how's the weight? The elevator accelerates upwards, accelerate downwards, and is at rest. Yeah. That's what I was thinking because, and I did say that earlier, you can go back. This is DVRable. He says that the book is saying it's A, but I just used the condition of the elevator. When you're in the elevator and it's going, you're on the ground floor and it's going to the, I don't know, the 9th floor. All right. And it's accelerating you upwards. So your weight is increasing because your inertia initially is going to fight this elevator. When it's at rest on the ground, your inertia or the tendency of your body to stay still is like, look, we don't want to go nowhere. But the elevator says, nope, boom. So the first thing you do is you feel it in your knees because your weight is kind of like bearing down on the floor of the elevator. So your weight is increasing. Now it comes and it stops. Now your body's like, yo, you took me for this ride. Now you want to stop. But you feel the weight shift up. You can feel it in your body when the elevator stops. It's like, oh, it took you for a ride and it just kind of let you go a little bit. So the inertia of your body wants to keep going upward. So that would be the decrease. And then when it's at rest, then it settles down and it remains constant. So I would have went with A at the end of the day. I just wanted to, with these word problems, you have to be very, very careful. And I'm probably, during the live stream, I definitely, want to get everything right. I don't get everything right. Sometimes I don't get all the questions even sometimes. I get about 95% of them, but you know what I'm saying? I'm like no superhero. Weekly, I show you guys a structure every week of how to attack these questions. And I teach this when I'm tutoring and stuff like that, this method, line by line, and just diagram. Get all the scrap paper you can when you take these exams as well. Your narration for what your body says. You know what I'm saying? So, I do a lot of math. Like I tell people, a lot of people are like, oh, you're so smart. I see your videos. Oh my God, like you're the best. And I'm just like, okay, I'm glad you like the video, but no, I'm not some super genius or anything like that. I do a lot of math. So I should be pretty good at it if I do a lot of math and I tutor it and I try to teach people different ways to attack questions. I should be good at it. I think I'm good though. I think I'm pretty decent though. I don't think I'm a bad tutor. If now you can just put it on the message board. Speak now or forever hold your peace. But Kino sucks. Yeah, only the trolls. Only the trolls out there. Okay. Translation for my SIFT people. All right. As we look at the helicopter from a top view, see, I didn't forget my SIFT guys. We have a helicopter. Here's the main rotor. But we have to understand that this main rotor turns counterclockwise. All right. Newton's third law of motion. For every action, there's an equal opposite reaction. All right. So we have the main rotor turning, and then here's the body of the helicopter, and then we have the transmission, the tail boom, and then we have the anti-torque pedal, the counterbalance, the torque. So this is the action. Action will be in red. All right. And so the action of this tail rotor will be here. All right. So it's going to draw air this way. That is the action. And this is the counterclockwise turn of the main rotor. What you guys do with my markers? Okay. So I really wanted a really contrasting color, not this color, something to contrast. All right, so that is the action, and the reaction, Newton's third law of motion, is this way. And although this is sucking air this way, it's going to be blowing that way, but the result is that the tail is going to want to go that way. So the translation tendency happens because now we got two forces working us in that direction. So this helicopter is going to have a tendency to drift to the right. All right. This will be the left side, and this will be the right side. All right. So translation tendency, we got the counterclockwise turn of the main rotor, and the reaction is for your nose to want to go that way. Right? But then what do? You use your anti-torque pedals to counterbalance that, but you're also producing thrust, sucking air through this way to keep your nose positioned that way. And so your tail is going to be there. So now you have two forces that are kind of drifting you that way slowly but surely. All right. For my SIFT people, was that clear, people? For all my SIFT people in the room. I'm sorry, not to exclude the ASVAB and AFOQT guys and all the other guys. But I just want to make sure that was clear to you guys, because when they talk about translation tendency or translation, whatever it is, but you can see the concept in your books as you go along. And you guys, the first 4 chapters of the helicopter flying manual or helicopter rotorcraft flying handbook, yeah, or helicopter flying handbook or rotorcraft. I don't know which one it is, but I've talked to you guys one-on-one. You guys know which ones you guys need to get. Hell. All right. Let's go to the questions. Oh, wow. we got a super duper question. And it's good some of you aviators are coming to the channel and asking questions because you guys are training. This one concerns landing under instrument flight rules. All right. And as a flight instructor, I'm always going to be a flight instructor. I may not actively be a flight instructor, but I'm always going to be in a flight instructor type of mode, promoting safety and following the regulations and things of that nature. So here we go. The question is asking about the rules regarding landing under IFR. Now, a lot of you guys don't know what IFR is. It is instrument flight rules. On a nice, clear, sunny day, that is visual. You'd be flying under visual flight rules. But when the sun, when the clouds come down and the visibility reduces, you have to fly under a different set of regulations, and there's certain things that apply. You have to have a special certification, even flying that type of weather and stuff. And I used to be really, really good at teaching guys that when I did it full time. So here's the thing. You are going to come down on most of the times, an instrument landing system is going to bring you down to a runway. There's our runway. Before that, you guys always see the movies, the lights, the approach lighting system, and you see the light pop, 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 pop. It like is pop, 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 pop. They're going in sequence. That is called a rabbit. That's what they call a rabbit, right? And so this is an ALS, or approach lighting system. So now, when you fly a particular approach, it's going to bring you down to about 200 feet above the threshold. So let's say this threshold area is, I don't know, let's say it's 100 feet above sea level, means sea level. That means on your altimeter, all right, which measures your altitude, you're going to come down to about 300, all right? But you're still 200 above the threshold, 200 feet. And guys, I'm sorry, I'm going to try to make this as simple as possible. But don't get caught up in this. The person asking this question understands what I'm talking about. So the touchdown zone elevation is 100 feet above sea level, and you're going to step down to 300 feet on your altimeter. So you'll be typically about 300 feet. Now, mind you guys, this whole time, we can't see the runway at all. We use our instruments to navigate to the final approach course, or what we call the extended runway center line. And don't worry, it's not dangerous, because if you've been trained properly, you can do this fine, no problem. So basically, you're not going to get anything, you're not going to see anything on really, really nasty weather days, all right? Or sometimes it's not even low cloud. Sometimes the visibility is just crappy. You don't have the horizontal visibility. All right, so what your approach is going to clear you down. So let's say this is an instrument landing system. This is going to let my aircraft come down to, don't laugh at my artwork, guys. This is going to let my aircraft come down to 300 feet above sea level, which puts me 200 feet above. Now, it depends on the particular approach. All right, this is not every approach, because I get to trolls be like, not at my airport. Okay, this is just a generic example. All right, so we'll come down to 200 feet above the 200 feet above the touchdown zone elevation. Now, at this point, we have to go visual. We have to see something. We got to see something. We have to see that rabbit on the approach lighting system. All right, you've got to see that running. You got to have the approach lighting system. But that only gets you down 100 feet. All right. And so now we are 100 feet above the touchdown zone elevation. Now, if at this point you do not see what I used to say, I used to have a memory aid. I would always say, threshold lights, threshold lights. So it would be threshold, runway, and touchdown zone, right? Threshold, runway, and touchdown zone. Threshold, runway, touchdown zone. So TRT. You need the threshold, lights, markings, or threshold. All right. Threshold markings, threshold lights. All right. Runway lights, runway and identifier lights. VASI. But touchdown zone markings, threshold lights, threshold markings. So you got lights and markings. So when the examiners are asking you questions, think of threshold and think of touchdown zone, lights and markings. You just named 4. You said threshold lights, threshold markings, touchdown zone lights, touchdown zone markings, runway lights, runway markings. All right. So that's 6 items that you can use. If you're giving them 6, they're going to back off you for your oral. What do I need to do to continue down past the extra 100 feet after we've seen the approach lighting system? So now that if I see the threshold runway or, excuse me, the threshold runway or your touchdown zone lights, then I can come down and I can land. All right. But not before that. Now, at that point, if you don't see that, then you have to do what's called going missed. You're going to execute a missed approach procedure. And maybe try to come around and try it again. And if not, then go to your alternate airport. It depends on your fuel. So I'm sorry, guys. I know that was long, but, hey, you guys, they asked, so I addressed it. All right. But I am, all right. Good question. Mario comes in with the question. All right. So hopefully that was like email to me from someone that was at work, and they wanted to see it in this DVR session. So I think his name was Fred. All right. But thanks, Fred, for the question. 4/5 divided by 6/7. Divided by, this is how you typed it in. Divided by 6/7 times 1/2 plus 3/2. All right, Mario, you're going to have to type in my options. What are the options on the message board? Please, sir. Please, sir. So, but the way he has it typed, it looks like he has 4/5 divided by 6/7 times 1/2 plus 3/2. And I already know what I'm going to do. Hey, Caroline, how are you? All right. Mario, are you there, buddy? 5/30ths, 57/30ths, 56/30ths, 57/30ths. All right, 56/30, 57/30, 58/30, 59/30. Bang, bang. Okay. 1, 2, 3, 4. All right, so it looks like there's only 4 options. 56/30, 57/30, 58/30, and 59/30ths. When I see this, the only thing I'm going to stick with is please excuse my dear Aunt Sally. Keeps you out of a lot of trouble. Sometimes it's hard to maintain the structure, but okay. There are no parentheses. Bang. There are no exponents. Bang. But there is some multiplication here. And it is the 6/7 times 1/2. So I'm going to deal with that. And I'm going to get 6/14. All right. 3/2. 4/5 comes down. Now, we're dealing with multiplication. We did the multiplication. Division is next. Here's the division. So I am going to divide 4/5 by 6/14. And this just becomes a multiplication problem. I got to make sure I'm not running out of real estate. All right, so 4/5 times 14 over 6. We merely just flip the numbers here. We're multiplying by the reciprocal. And 14, 16, 56. Yeah, 56 over 30. All right, so we would get 56 over 30 at this point. And then 3 halves we would add. All right, so 3 over 2, or this would be 1 and 1/2. I could keep it either way. All right, so 56 over 30 plus 3 over 2. What I'm going to do is I'm going to just use my method, and I know it might be a little crazy, but I'm going to do it anyway. 56 times 2 is 112 plus 90 over 60. All right. So I will get 100. Well, listen, let me just see. 0. No, that's 2. 2 and 11. 212. And let's see. That'd be 56. Let's say 56 over 30. Because 212 over 60, if we divide both of those by 2, then we should get 56. No. That'd be for the 100. All right. 212. I would get 106. 106 over 60 over 30. And wow, there's nothing with 15s in it. All right, let's just see where this goes. And this would be 53 over 15. 53 over 15. Even if we converted that to 30ths. All right, I got to look at that again. That was a mess. Yeah, I got to look at that again. And guys, start sending your emails now if you are interested in coming to the Google Hangout. If you're interested in coming to the Google Hangout, please go ahead and send me those emails in now, because that's going to be the last question for the free live stream. Now, people that are new to the room, I'm here every week, offering, you guys present questions, I answer them. Not only for math, but military aptitude test prep, I prepare for all of them. Every Federal Aviation Administration test for pilots that is out there, I've taken and passed it. From private pilot all the way up to airline transport pilot, and all the flight instructor and ground instructor ratings. All right, so if you guys don't understand something, this is a free resource. I'm here every week. It's a free resource. Nobody's paid for anything in this room except my clients that work with me one-on-one. All right, so I don't stop doing this. I do this every week. So if you're having problems, don't sit there and try to struggle with it. Just bring it to the room. Even if you want to be anonymous on the email, just say, look, keep me anonymous. Don't say my name. That's fine. I'll execute the problem anyway. So I'm here every week, guys. Take advantage of my expertise. All right? Take advantage of it. I'm here every week. I'm not doing anything. I'm going to get some hot wings later, but I ain't doing that now. So if you are interested in coming to the live stream, please send me the email right now. And if you guys get a chance, and Ileana and Mario, I guess I will, I see you guys coming in, okay. All right, so yeah, I'm rebooting my other computer now that I'm going to be using for the live stream. Because you know what, it takes a while. So now I decided, you know what, do this, go live on the one camera, and then I can just have it set up and ready to go and stuff. But it looks like we have 2 people so far in the live stream. Julia, you are welcome to come to the live stream as well. So make sure you send me that email so I can send you a link. Unless you have something to do. All right, and I will be taking, if it takes you 10 minutes to send it, don't worry about it. Okay, no problem. I'm just letting you know, that's all. My computer's still doing its thing. And what I want to do is I'm going to start, I should have done this earlier, but I'm going to start synchronizing. So like right at 10 o'clock, I can, boom, go right into the live stream to make it almost seamless. But thanks for coming out, guys. Send your emails if you're interested in coming to the live stream. And that... Oh no, I still have another hour to crank out with the people that are going to do the Google Hangout. And then after that, oh, I don't get out much. Well, I get out, like traveling for work, but just for me, I don't get out much. But that's all right. I know. No, it's really not that bad, but I'm gonna have a good time tonight. After I get done with the Google Hangout, because I need to get out more. Yeah. So, all right. Thanks, guys, for presenting your problems, coming out to the live stream. It is time for the finger, not the middle one. It's the forefinger. I'm not giving you the finger. I'm just. Oh. That's what I'm going to start.